Yeah, it's magical. Alrighty, hi everybody. I know I believe we're up on YouTube starting now. Hi to Phil in the chat. The usual warning for folks joining on Zoom. If you want to chat with other people, make sure that you change that little bar, that blue, or the little bar in your chat box from all panelists to all panelists and attendees, so that you can talk to everybody. Hello from all over the country, so far the province. We'll hopefully get some folks from outside of Ontario in a little bit. And also welcome, I know that some of our friends shared the link as well, so welcome to the folks who are joining us from King City. Today is going to be entirely about Mars, because this whole week is entirely about Mars. Everything right now is about Mars.
That's right. Unless we run out of, if you run out of things to say and people have questions about other things, we can always throw in a few other comments. But yeah, Mars is the focus.
Mars is the focus. So yes, as always, feel free to ask questions as we go along. We'll try to answer questions both from the Zoom chat and from the YouTube chat. And we're going to talk a lot about how to observe the red planet today. But yes, happy to talk about other subjects as well. And that is enough vamping. That gets us to 3:30.
All right. Yeah, welcome everybody. So let me just put my chat away here. Right.
Chris is our expert on this because Chris has been out observing Mars multiple times already, whereas I have only been talking about going out to observe Mars.
I made an effort. I went out last night. I brought out my 12-inch Dob Newtonian reflector, and I brought out my 80mm refractor, and I had them set up to show roughly the same magnification of the planet. And I've never seen it looking so good. I was just blown away. But I'll jump ahead a few minutes and just let everybody know, if you plan to look at Mars, right now, any size telescope should show you Mars at least as a little disk. But the trick, the real secret, is to take your time. So look through the eyepiece for a minute or 2 minutes and just watch. And if you've got the slow motion controls in the telescope that let you track it as it drifts, just have your hands on them and nudge it along, because you're waiting for the sky, you're waiting for the Earth's atmosphere to sharpen. Suddenly it'll sharpen and Mars will become crystal clear if it's in focus. So that's what you want to watch for. People that just glance in, oh, I saw it. That's not good enough. You're not seeing the special details. So anyway, we'll get into a bit more of that as we go.
Mm-hmm. And we'll talk about imaging too, because some of the imaging has to do with that. And if you ever wonder why the pictures look so much better than what you might see in the telescope, we can help explain that too.
Yeah, so I guess we can get started. Let me just share my screen here. So what I did is I write my astronomy skylights every Sunday, and this Sunday past, I wrote about Mars. But this Mars Madness, or Mars Fest, if you want, is broken up into 2 weeks. And because of something that I'll explain in a little bit, Mars was closest last night or early this morning, but it's not at opposition till next Tuesday. So last night, Mars was the biggest it'll look in telescopes, whereas next Tuesday, Mars will be brightest in the sky, just because the sun will be shining straight on the planet and reflecting back. And I watched your Explore the Universe, and you were looking at the magnitudes going up past last night. And that's what you were seeing, is that actually in Stellarium, if you look at Mars, if you've got your info set up right, it'll show you the phase, the amount of the planet illuminated. And you can see that it's less than 100% illuminated now, and it'll grow to close to 100 next Tuesday.
So that's something that the media has had some trouble with, not just me too, but like the media as well, with that differentiation between opposition and closest approach, and that they are a week apart with Mars. So October 6th in the morning, so that was this morning, was closest approach. And then October 13th, which is a week from today, is the true opposition, where Mars, Earth, and the sun are all directly in line.
That's right. And I've got some cool simulations of that in here. So what I'm using instead of Stellarium right now, I'm using a program called Starry Night, which is, it's not free, which is why it's not as widely known, but it's outstanding. It's a three-dimensional rendering of the universe, so that you can use it as a planetarium software, but you can also lift off the Earth and fly from place to place and orbit planets and do all kinds of cool things. And so I'm going to show you some views of Mars using the features in this software that you don't get in Stellarium. But you'll be able to emulate some of what I've got going in Stellarium. So let me just break down. Sorry, Jenna, go ahead.
I'll just mention briefly that when I got my telescope, which was, in all fairness, it was new, it came with a copy of Starry Night. So there may be some promotions out there with certain telescope companies. I got mine from Ontario Telescopes, since there may be promotions out there where you can, not that it saves you a ton of money in the process because telescopes are expensive, but where you may be able to get a bundle.
Absolutely, yeah, keep your eye out. All right, so what I'm gonna do is I'm gonna switch us to a space-based view of Mars. Okay, so this is looking down on the solar system from above, from north of the sun. We call this north of the sun. And when you look down from above the plane of the solar system, then all the planets rotate counterclockwise around the sun. That's their orbits are counterclockwise. And you can see that I've magnified the sizes of Earth and Mars to roughly what they would be in proportion to one another, but not to true scale. So they're really, really small. You can see there's Mercury and there's Venus dots representing where they are, but here's Earth and Mars. Now, Earth's orbit is green, Mars's orbit is brownish red, as you can see, brown. And you can see right away that, of course, Earth is closer to the sun than Mars is. Everybody's pretty clear on that. But orbits are not perfect circles. Earth's is not too bad. The sun is nearly in the center of the circle, but it's a little offset. But you can see that Mars's orbit is really offset, sort of lopsided compared to the Earth's orbit. And what that means is these two orbits stay in this position and the planets, run along them. And you can see, so there are times when the two orbits are close together and times when they're far apart. And you can see this is the sky, this is the arrangement right now, tonight, October 6th, basically this morning. And you can see that Earth and Mars are relatively close together. Now, Earth takes 1 year to go around the sun, but Mars takes about 2 years to go around the sun. And what that means is that they end up on the same side of the sun about every 2 years and 50 days. So that's roughly 26, 25 and a half months. And so the last time this happened was in July of 2018. And 2 years ago, when that happened, I can put this back to 2018 in July. So you can see that they were in an area where the orbits are pinched closer together. So the last time Mars and Earth were at opposition and close to each other, Mars was closer than it is tonight or this week, but Mars was covered with a global dust storm. So we were all frustrated trying to see features on the planet that we couldn't see. Plus, when planets are visible in the summertime, they're low in the sky. When they're visible in the wintertime, they're high in the sky. And that's because if the sun is low at night, the planets must be high. The sun is low in the day, the planets must be high at night. It's a teeter-totter effect. Mm-hmm. And then in spring and fall, it's about 50-50. So the planets are not as high as they are in the winter, but much higher than they are in the summer. So 2 years ago, Mars was at opposition in late July, which meant it only got to be about 20 degrees above the southern horizon at its peak. And that's not good for observing because you're looking through so much of Earth's atmosphere. This year, in 2020, I can reopen this by doing this. So this year, they're still in the sort of narrow, but they're kind of leaving that narrowed, close together section of their orbits. But this year, because opposition's happening in October, the ecliptic is higher, and so Mars is going to reach more than 50 degrees above the horizon for people living in the sort of Greater Toronto area and southern Canada latitude. So that's a much better time for looking at a planet.
Can I just jump in quickly because a lot of news sources have been saying things like, this is the closest it'll be for 15 years, or this is the best view we'll get for 15 years. And that usually has to do with how close in our orbits we are. So while we were closer last year they might have said, this is the closest we'll be for 17 years. And now this year we get to say, this is the closest we'll be for 15 years. And then so on and so forth until we get back to that 15-year mark. When
Yeah,
we're
so
closer to
basically
our clock.
2018, it was this one. 2020, it's this one. 2022, they'll be much farther apart, as you can see. And then 2024 or 5, and eventually it cycles around and the cycle repeats. So 2035, which is what you've been hearing about, and we can go 2035, I don't know the month.
Hey,
But it
it's
looks
close.
like it's basically, let's see if I can wind it back a little bit
It'll-
here. So that's about opposition. So in September of 2035, they'll be roughly where they are today.
And they'll be ever so slightly closer together, but not much noticeably closer together.
Yeah. Now I'm just going to wind back a few days. So here's October 1st. Now you can see that there's an angle between Earth and Mars. They're not, they're not in a line. And so what's happening is that every day they're both marching along the orbits. And you can see that the orbits are actually diverging, right? And so that means that every day the distance is getting a little bit greater and greater because Mars is sort of pulling away from the sun. And that's why, and this last night, the two planets are technically as close as they were going to get, but a week from now, when they do line up, it's around the 13th or so, they've actually gotten to the point where their orbits are a little bit wider apart. And so that's what the differences between last night and next week is. But Mars is super fantastic to look at all this period, right? So as I said, the size in a telescope was maximum last night. It'll be brightest in the sky next Tuesday. And then after next Tuesday, they really start to pull apart. And so I'll show you, I might have time to show you a graph of brightness over time and size over time. It really drops off rapidly for the rest of October and on, even though we're going to be able to see Mars until next May. It's just that it's going to be getting farther and farther and tinier in the sky.
I guess that happens a lot where people say, like, well, where did Mars go? If the best time is to observe it now, it doesn't disappear. It just gets really uninteresting.
Yeah, actually, good point. So if I jump to a year from now, so exactly a year from now, the Earth's going to be where it is in this diagram. And look where Mars is. It's over here. So at this point, not only can we not see Mars due to the glare of the sun in between us, but also Mars is, what is that, about 10 times farther away from the Earth than it is this week.
And Mars is actually one of the few planets this really happens with, because if, Jupiter and Saturn are pretty good a lot of the time because they're so far away that sometimes moving around through the orbit, sometimes it's not as great, but, they're still really far away no matter what. Whereas Mars can either be like 3 light minutes away from us or 20 light minutes away from us or something like that. So
yeah, actually last night, so I wrote the numbers down. Let's see if I have it here. Position. So as of this morning or last night, Mars was 62 million kilometers from Earth. That's 0.515 astronomical units, or the mean Sun-Earth distance. So it's a bit hard to tell from this, but that's actually half of the Earth-Sun distance. And 3.45 light minutes away.
So if we gave Mars a call, or we tried to talk to the rovers, it would take 3 minutes for our how many was it? How many?
3 and a half minutes.
3.5 minutes to get there. And that's when they talk about colonizing Mars and like exploring Mars, that's one of the issues, is that it's so far away that sometimes it's only 3 minutes away, and that's not so bad. But then sometimes it's on the other side of the orbit, and then it takes a really long time for any information to get there.
That's right. So a year from now, I just showed you that diagram with Mars over here, just to put the numbers on that. That's 393 million kilometers instead of 62. And that's 21.8 light minutes.
Wow.
So that'll be 21 minutes, almost 22 minutes time for radio signals to get from Mars to Earth a year from now. That's why we plan our space missions around the oppositions. And by the way, opposition, I think everybody probably has figured out, opposition means that the planet is opposite the sun in the sky. So if Earth is in between the planet and the sun, then as the sun goes down, the planet's coming up, and vice versa. So that's what opposition means.
that also makes a difference for people who are going out to observe, because let's say now, if you go out right now, Jupiter is past the middle of the sky, I think at this point almost. Jupiter is all like, you only get half the night to look at Jupiter, but if on opposition, you get the entire night to look at Mars. You get from sunset to sunrise the next morning.
Yeah. Yeah, and in 2018, because Mars was at opposition in July, it didn't even get dark until 10:30, 11 o'clock. And so places like the Ontario Science Center that wanted to do Mars fests, you know, we had to set up our telescopes and have people wait around quite late to see it.
And
the
it was
other
covered
thing
in a
that,
dust storm.
yeah, the other thing that's going to happen is that because Mars rises about 5 minutes earlier every night, then each week that goes by, Mars is available about half an hour earlier, right? So even though Mars will be starting to get a little dimmer and a little bit smaller towards the end of October, it'll also be shining high in the sky at a much more convenient time of the night. So right now, Mars gets to its maximum height above the southern horizon about 2:30 in the morning. Even by next week, by next Tuesday, it's going to be, I think, around 1:30 or a bit earlier than that. And then the following week, it's going to be nice and high quite early in the evening, so 9, 10 o'clock in the evening. So to make it much more convenient to see Mars when it's at its best, at its highest.
And that answers the question that's in the Q&A right now from Ryan, which is what's the best viewing time of day for Mars right now? And that answer is what Chris just said, which is as whenever it's at its midpoint in the sky, as high up as it'll get as it goes through the night sky, because that's the least amount of atmosphere that you're looking through.
That, I mean, that's your theoretically best time, but I was looking at it at 9:30, 10 o'clock, and it looked fantastic. And maybe if I'd stayed up till after midnight, maybe I would have looked a little better. But just by waiting for those moments of crisp air, it was as if it was higher anyway, right? That's the secret.
You and Eric Briggs just described in his words in the YouTube chat, he described the view of Mars last night as, and
that's what I was saying too.
Yeah.
Molto bueno, yeah.
Molto bueno. Yeah.
So before we move on, let's just talk about space exploration for a second here. So let me just see if I can show this. So what I've got is this yellow arc is the trajectory of a spacecraft called Mars Express. And that was launched back in 2004.
I'm gonna add a point here really quickly that we're now looking from the opposite direction, right? We're looking from underneath the sun, Mars, because everything's going clockwise. Yeah. Okay. Just a heads up if you get confused about why they're rotating in one way or the other.
I won't play with that right now. I could flip it around. I won't play with that right now. So what we do is we launch a spacecraft and we give it enough kick so that we create an elliptical orbit where the semi-minor axis, the minimum distance from the sun of the spacecraft is Earth, and the maximum distance of the spacecraft is Mars. That's the shape of the orbit. And we launch it at the right time so that when it does reach that maximum distance from the sun, Mars is there to greet it. So we don't put engines on these spacecraft. I'll just start this again. We just launch them with enough speed that they coast.
And this is, when you're talking about orbital mechanics, I always have a hard time with orbital mechanics, but essentially if you launched this and it didn't intercept with Mars, then it would continue on an orbit around the sun, correct? It would just keep going.
Yeah, so if you launched it with the same speed, but at the wrong time, then it would just do that shuttle service between Earth and Mars's orbits, but the planets wouldn't be there to greet it when it got there. Yeah, exactly. All right, so let's talk about, I'm just gonna go opposition 2020. So what all this looks like from the ground is that Mars started becoming visible before dawn several months ago. And because it's rising, earlier and earlier every night a little bit, now it's finally rising close to sunset. And then a number of months from now, it'll be sort of swinging into the western sky and getting smaller, but we'll still be able to sort of keep an eye on it. We can look at that in a few minutes if you want. But here's how to find Mars. So you need to go out, and at about 10 o'clock, it's going to be, I'm not sure how high is this altitude, a couple of fist diameters above the horizon. So You may have trouble spotting it initially if you go out too early because it could be behind a building or a tree or a hill or something like that, right? So you want to look around, look towards the east or southeast for a bright red sort of beacon in the sky. Nothing around it is going to compete with that brightness. Mars is actually brighter than Jupiter already.
Right, I guess it is, huh?
Yeah, yeah. So
Wow.
it's actually crossed that threshold a week or two ago.
Jupiter is typically, wait, is Jupiter the second brightest object usually in our sky, or is that Venus?
Venus is number
Jupiter?
one. Well, after the sun and moon.
The sun. Yeah.
And it's Venus and Jupiter. Yeah. Except at times like this when Mars can go brighter.
And it's certainly, Mars is certainly the most colorful of all of them.
Yeah. If you're out at 9 or 10 o'clock, then you can catch Jupiter, Saturn, and Mars all at the same time. And you'll notice that Jupiter is white, Saturn is yellowish, and Mars is reddish, for sure, reddish. So Mars has been sort of crossing through the constellation of Pisces, and Mars is actually in retrograde right now. And that's because the Earth is in the process of passing Mars on the inside track of the racetrack around the sun. And I can demonstrate retrograde. Let's see if we can get this to work. Okay. So if I get this to play. So here's Mars.
And
this is
highlighting the date, is August 1st.
Starting back in August. And if I just let this play.
So cool.
So that's January 2021. So if I go back in time, I won't do it that way. So you can see that before a certain date, I forget the exact date when it paused, but as Earth is catching up to Mars, they're both going in the same direction, of course. Then the stars in the background seem to be traveling to the west of the two planets. But as soon as Earth begins to move between Mars and the distant stars, then we start, because we're faster, we start seeing Mars going backwards. It's just like we're in a fast car on the highway. There's a slower car on the highway. I know you told the story the other day in your Explore the Universe.
I told it because you told it.
Yeah, the distant mountains in the background. So the mountains can seem to be going, the slower car can seem to be going backwards compared to the mountains for a while. So after we pass Mars at opposition, which is sort of somewhere here in the middle of this loop, this is called a retrograde loop. Sometimes the loops close up, but Mars, in this case, it's sort of a zigzag. At opposition, we sort of are in the middle of this loop. And then in November, this is November 7th, I guess, we'll move ahead of Mars enough that now we are both moving east compared to the stars again. And so the retrograde motion will end. So I can play that again just quickly, just so you can get a sense.
If you ever hear in astrology about retrograde motion, that is what they're talking about. It's actually kind of cool just to plot it. So you can actually kind of keep an eye on Mars, go out a couple times in a week maybe, or in 2 weeks, and just see what Mars is up against, like which stars it's up against, and plot its movement and watch it move. Because I mean, it's a neat way to feel small within our solar system and to really feel like it's another planet out there.
So somebody actually emailed me to ask about retrograde motion, and that I said that Jupiter and Saturn were retrograde and that they didn't notice them moving to the left or to the right or to the west. And I said that it's only compared to the stars. It's a relative motion, not an absolute motion, because everything goes across the sky overnight, and everything, all the constellations, migrate, and the planets migrate by a few minutes every day because of the Earth's motion. But what I can do is here, I can set this up to sidereal day. And if I step this forward, you can watch Mars compared to the, I'll just zoom in here, these stars that make Pisces. And can you see how Mars is moving away from those stars? Because that's that retrograde motion. Yeah, and then eventually it'll start heading back again. So that's opposition. Let me just put this back. All right, so what are we going to talk about next? Any other questions so far?
There's a question about imaging / observing Mars with filters. Do you want to talk about that now or later?
That's coming up. Yeah, that's coming up in a bit. Yeah.
Okay.
All right,
we'll
so
let's talk
about viewing Mars. So I've taught you how to find it. You can see Mars after dusk, all night long, and even before dawn. It'll be in the west before dawn. It'll be shining as a bright reddish object before sunrise in the west as well. Basically it's an all-night planet right now. If you have really good binoculars, you might be able to see Mars has a disk. So I have what am I, 11 by 42 binoculars, I think, and I can see Jupiter's disk, barely. And
That's
Mars's
big.
disk is only half of Jupiter's right now. Mars has gotten to be almost half the size of Jupiter's disk. So you might even be able to make out that there's a disk of Mars in your binoculars. But any telescope, if you can get any little telescope, will help. And that's what you want to look at Mars with. All right, so let's look at Mars.
I definitely recommend if you have an old telescope lying around, is somewhere deep in a closet somewhere, pull it out and give it a try. Now is the time.
Yeah, give it a go. So this is how Mars looked, will look tonight. And what you see in a telescope, it'll be, of course, much smaller. What I can do is I can sort of simulate what I saw last night. I saw Mars sort of like that size, about 200 power, without the labels, of course. But I added these labels because if you've got an app like Stellarium, you can do the same view in Stellarium, and we can demo that if people are curious about seeing it in Stellarium. There's also a neat website that Sky and Telescope have called, it's called their, yeah, let's see if I can open this up.
It basically tells you which side of Mars is visible at any time, right?
Yeah, I'll open it up and I'll just drag it onto my screen so people can see it. Okay, it's called Mars Profiler. And when you open it up, you just dial in your date and time, and it'll show you with labels what's visible. So if I go, so October 6th at 11 p.m. in universal time, or in time at Greenwich, England, is 4 hours beyond that. So that would be October 7th at 3 a.m. So if I put in October 7 at 3:03:00 and calculate that, then that's the view it says should be visible. Except that this is north, let's see, I think it might be north down. Yeah, you can select which view you want depending on your telescope. So that would be binoculars with right way up. This would be a reflecting telescope like a Newtonian telescope or a Dobsonian, so it flips Mars upside down. And then if you have an SCT, I think you have an SCT, Jenna.
I do.
Or a refractor with a diagonal, then it flips it a different way. So you can use this little tool, and I think you can put that in the chat, that link.
I did. I sent it out in the chat. It's both in Zoom and on YouTube, so it's ready to go.
And so it's got the labels. So what you can look for is this dark Syrtis Major Planum is very, very obvious in a telescope right now. And the Terra, these dark blotches, they're really, really clear. I could see this sort of a crown effect. And again, it was flipped over for me. You want to look for the southern polar cap. So Mars, just about a month ago, started its northern winter, southern summer, which meant that its south pole is tilted towards the sun. And that means that the south pole is the one in view for us. The north polar cap is a bit hidden over the planet. But also it means that it's the southern hemisphere of Mars is warming up, so the polar cap is shrinking. So those of us that have been looking at Mars for a number of weeks now have noticed that the solar polar cap's gotten smaller. So look for a little bright white dot close to the edge of the planet. And depending on your telescope, it could be up here, depending on how your telescope flips the view. So it won't necessarily be at the bottom. It's more likely going to be flipped upside down and with the polar cap the other way around, and with this sort of Syrtis Major dangling down.
Is it worth noting that in a week the view will be slightly different?
Yeah, I'll show a view in a week as well. Yeah. So this word planitia is a Greek word for plain. All right. So you've got Terra, which is land, planitia, which is plain. And you've got the dark patches, you've got brighter patches. This is called Hellas. So that's a dark sort of an oval shape, and a few other things. And so Mars's day, let me just get this number here. Just get these numbers right. Yeah, Mars's day is about 38 minutes longer than Earth's day. So that means that if you look at Mars at the same time on Earth, Mars will not have finished rotating fully. Almost, but not quite. So if I advance the date here from the 6th to the 7th to the 8th to the 9th at 11 p.m. every night, you can see that if you go out every night and look at Mars, eventually you're going to see more of the disk, more of the globe. But you don't need to work, you don't need to do that. What you can do is start at 11 o'clock, 12, 1, 2, 3, 4, you know, by dawn, you've watched about half of Mars rotate. So you've gotten a lot of the globe that way. So a combination of watching it, you don't have to watch it all the way through either. You could set up your telescope, look at it, you know, before bed, get up before sunrise and watch it again, and you'll see a whole different side of the planet. And then if you really want to see the entire globe, maybe you want to sketch it or photograph the whole globe, then you can wait a couple of weeks and do the process again, and you're sort of seeing a different perspective. All right, so now this view is going to be roughly the same all week. As you can see, it doesn't change too much night to night. So, you know, less than an hour's worth every night. Okay, filters.
Yes.
So if you got filters with your telescope, and Jenna, you could actually cut and paste that little thing about filters that I've got here in the doc. I don't know if you can see that. So the number 23A is a light red filter. That'll emphasize any dust clouds. The number 25 red filter will show the ice caps and surface features better. The violet filter will enhance any clouds that might be on Mars. The light green can show the ice caps, and the 58 green can show the ice caps, clouds, and dust storms. You can experiment with different things. And one more important thing, Mars being so close and so bright, especially if you have a large aperture telescope, it might be almost blinding how bright it is. And so you can treat Mars as you would the moon. If you want to make the moon less, you know, less glary, you could put a moon filter on Mars, dim it down a little bit, and that'll increase your ability to see some of the contrast on the planet. Some telescopes have the sub cap on top of their objective cap. So you could put the main cap on and just take out the mini cap and shrink your aperture of your telescope, and you'll dim down Mars a little bit. Or put a pair of sunglasses on, you know, whatever you have at hand just to dim it down. It'll work.
Sunglasses may not be the best solution, but they are an easy solution that almost everyone has.
It's like Plan F, you know. It's okay. Let's jump ahead to next week. And as I say, any clear night from now until next week and even beyond, don't fret if you missed it last night or tonight. You know, any good night, try it. And I recommend trying it more than once. So here we are a week from now. And so that Syrtis Major section is sort of rotated off the disk. If you wait till later in the evening, it'll show up. So by 1 o'clock, Hellas and Syrtis Major and stuff are coming back. But at 10, you know, 9, 10, 11 p.m., you're seeing another side of the planet. So it's really fun. And we recommend that you try to sketch it. Just do a rough sketch. Maybe you'll see canals like Percival Lowell did, you know. Nowadays, with our good telescopes, we wonder, how could he have been so mistaken? But, you know, they worked with what they had.
People also thought that there were oceans on the moon. So it's things have advanced these days. And also recommendation when you're sketching, sketch the darker stuff first and the lighter stuff later, because I'm slowly figuring out how to sketch things that aren't just stars. It's taken a while.
So let's talk about a couple of other things. Let's talk about, any questions so far?
So far we're good, although we had a confirmation from Graham White that they saw Mars as a disk in binoculars last night for sure in Manitoba. So you can see it as a disk in binoculars depending on the pair of binoculars that you have.
Very good. All right, so let's get into some other fun stuff here. So The other thing that you can try to do during opposition periods is see if you can see Mars's two moons, Phobos and Deimos. They're pretty dim. So Deimos is a magnitude 11.75 and Phobos is magnitude 10.66. So those are like dim stars. You'll want to pick times where, you want to pick times where the moon is farther away from the planet so that it's less in the glare of the planet. I've done it. It's really difficult. You need a big telescope, really good sky conditions, and as I say, a time when the moons are farther away, but it is possible to do it. Let me just open this up again.
It's tricky because Mars is so bright compared to them.
Yeah. So the planet itself is very bright and the moons are many orders of magnitude dimmer.
Mm-hmm.
So let me just show you where they are tonight.
It's the same way that if the moon is up during the day, it's way less noticeable because the sun is up. It's equally bright, but the sun is there.
Now you can see that night to night, the moons do change their position. So you can, wait for times when Phobos is a little farther from the planet. Phobos is the closer moon, and Deimos is the farther moon.
I have a question from Heather, who is one of my favorite people. Hi, Heather. Thank you. Does Mars rotate west to east like Earth, or counterclockwise like Earth?
Yes. Unless they're disturbed, we think that unless a planet has been disturbed since it was created, because everything coalesced out of the protostellar, the protoplanetary disk around the sun, everything had the same angular momentum. So all the planets orbit the same sense and they rotate in the same sense. But there's a couple of exceptions. So Venus got knocked over and it rotates the wrong way. And is it Neptune got knocked on its side? Yeah. So it sort of rolls over. And Pluto also sort of rolls over. Pluto is a Kuiper belt object, so it's allowed to be a little bit odd. But of the classical planets.
Yeah, Phil jumped in to clarify that it's actually Uranus that's on its side.
Uranus on its side, sorry.
Yeah, but it's essentially the theory is that they all started spinning counterclockwise, and that Venus got hit, and now it appears to spin clockwise, but originally would have spun counterclockwise, just the other way around.
The planetary scientists think the early solar system was a bit of a shooting gallery. There was planets zipping around and maybe merging and knocking into one another, maybe getting thrown out of the solar system. We think that's how our moon was created, by something as large as Mars, struck the Earth a glancing blow. And because it was a glancing blow, it mostly ripped off Earth's crust rather than knocking into Earth's core. And so when that crustal material recoalesced into the moon, the chemical composition, the mineral composition of the moon very closely matches Earth's bulk crustal composition, because it's formed of the same material that's been ripped off and then coalesced as a separate blob, basically.
That answers a question from one of my friends once, that why isn't the moon iron like our core? But it's because it didn't catch the core. It's because it was mostly because it's basalt, right?
Yeah, and the theories that I read said that the moon, so the Earth would have had a ring for a while. That debris would have formed a ring. And within about 100 years, just a few hundred years, that ring would have then coalesced into the moon.
Cool.
And then it differentiated. So all the heavier elements would have collected in the center of the moon, and the lighter elements would have floated to the top. So that's why the moon's bright white rock, which is an aluminum rich, aluminum being a fairly light element. It's an aluminum rich rock, crystalline rock that makes it very reflective and shiny, is on the crust. So the moon has heavier, darker, more iron rich material in the core, and that material is what got upwelled and filled the basins to produce the dark maria. So the dark maria are basalts, and the cratered, brighter areas of the moon are this anorthosite rock mineral.
Cool.
Yeah. All right, so let's talk a bit more about Mars exploration. Oh yeah, so as I was saying about the moons, make sure you know, give it a go. If you've got good sky conditions, a big telescope, and you can even try photographing the planet and see if you pick up the moons in those photographs, you know, take a good look at them. I am not an expert at imaging, but we do plan to do more events. We're planning to do one next week, and we'll have some people on that will be live streaming views, hopefully, of Mars, and can speak more authoritatively about how their imaging rigs are set up. And
I'll plug that event real quick with more detail, which is that we have a guest speaker, Erin Gibbons, who's a PhD candidate at McGill and is studying the possibility of microbial life on Mars. So she's going to talk about her research and also her role on this Space Generation Advisory Council, which should be pretty cool. And then we'll have all of your live stream favorites. We've got Chris, we've got Ryan Marciniak, and we've got John Reed. So Ryan from the Star Parties and John Reed from Explore the Universe. We're all going to hang out and image and show views of Mars with various different telescope setups. And as long as the skies are clear.
Exactly. All right. So what I'm going to do is talk for a little while about Mars geology, Mars exploration, and things like that. So let me just center up on Mars here and zoom in a little bit. So what I'm going to do is I'm actually going to fly us to Mars. That'll be fun. Let's go home. Let's pick up Mars in the evening. This is always fun to do in the planetarium. Mm-hmm. All right, where's Mars? So I'm going to do this, and I'm going to say, go there. And we're actually going to lift off and fly into space and go to Mars.
I love a good trip to Mars.
Here we go.
Tell us in the chat if you would go, if you had the option to go to Mars, would you go to Mars? Because I'm curious as to how many of you would hop on that, what is it, the Falcon Heavy that's planning to go over there and go and check it out.
It's cold.
Cold, and there's like not much air, but there's less gravity, so the rock climbing will be really good.
All right. So what I got here is a 3D model of Mars. And what's cool about the software is I can actually paint Mars with different skins. So what I'm going to do is I'm going to show you Mars's global topography. So this is actually data rather than a photograph. It's actually numerical data, color coded. So you're looking at white and red areas are high elevations, so mountaintops and hills. And then the blues and greens are lowlands, low elevations, so valleys and so on. And you might notice that there's a big section of Mars that looks low and flat. And I always ask students when I'm in the planetarium what that reminds them of. And sometimes they get it, sometimes I nudge them, but it's basically reminds me of the Pacific Ocean basin, right, on the Earth.
It helps that it's colored blue in this diagram.
Yeah, I know that. So we now have a pretty good sense that Mars had a global ocean millions of years ago, and it was a much wetter place. And I don't know if you can see, but there's a prominent crater here right in the middle of this view. And that crater's name is Gale Crater. And that Gale Crater is parked on the boundary that may once have been the ancient seashore. So the sea would have been up here and then the hills behind it. And that crater is where the Mars Science Laboratory, or you better known as the Curiosity rover, was sent. And the reason that they picked this crater called Gale Crater is because they hoped that they could detect rocks that were from the seabed or submerged, that had been submerged in water, as well as rocks that were never submerged in water. So a really neat contrast in the Mars's geology. There's a peak in the middle of this crater. It's like basically a mountain, and the mountain has been eroded. This once was a lake, actually, but the erosion has exposed the flanks of the mountain. And now the layers of Mars's history can be read in the layered rocks. And so the rover is in the process of climbing the mountain in the middle of the crater. That's what it's been doing for the past 6 or so years. It's nuclear powered, so it doesn't have to worry about Spirit and Opportunity getting dust on their solar panels. So basically it'll run, as long as nothing breaks on it, it'll run for a good long time. And it's basically reading Mars's geological history as this climbs this central mountain peak. And so they have found minerals that were either formed in the presence of water or that have been altered in the presence of water. Everybody knows alteration, but you may not recognize it. Alteration you could think of as rusting. So if you take a piece of steel or metal, and that's a mineral, and over time, if that gets exposed to the elements, water, air, and so on, it can rust. And what you're doing is you're taking that mineral, that element, and you're converting it by oxidizing it with the Earth's atmosphere. And so the reason Mars looks red is because it's rusty. The iron in Mars's soil, and among other elements, have oxidized through weathering and have turned into this rusty red color. And if you go online and look for photos of the drills, the cores, the holes that Curiosity has drilled into Mars, once it breaks through the outer layer, the rocks are gray. They're light gray dust underneath. So it's just the outside that's red, and the rocks are actually gray underneath. Pretty cool.
That's super cool. I have a question from Kate. Can I ask you the question?
Yeah.
I don't know. I know you're not. Oh, wait, no, you are a planetary. Okay, never mind. You're a planetary geologist. What would cause the planet to lose its ocean?
Oh, that's a good question. Thank you for asking that question. So do you remember that initial picture I showed of the solar system top down? Let me do that. Mars is about half the diameter of Earth. And that means it's a quarter of the volume or a quarter of the mass of Earth. So it has way less gravity. And so the gravity is what's gripping onto the atmosphere. And when you have less gravity, you can't hold on to your atmosphere as easily, and it can escape on you. So the Earth's atmosphere is slowly, very slowly ebbing away, being lost into space. And that process happened much faster on Mars. And also Mars didn't have a magnetic field the way the Earth does. So Earth has this dynamic iron core. Mars being smaller has a smaller core. It cooled off faster. It's not as, we think Earth's core is in motion. That's producing the magnetic field, the dynamo around the Earth. We think Mars being smaller, cooled off faster, became inert. And so the magnetic field sort of collapsed. And the magnetic field was not able to fend off the sun's bombardment. And the sun is actually also spinning off the atmospheric molecules from around the planet. So it lost its atmosphere, it cooled down, and anything volatile, which includes gases and liquids, would then be lost. Or as everything froze up, frozen into the soil.
Which there's some evidence to suggest as well.
Yeah,
right?
we've been discovering subsurface lakes on Mars now under the polar caps. And in my other life, I was an exploration geophysicist, and I worked with ground penetrating radar. And ground penetrating radar is cool. You beam a radio signal into the Earth and then you listen back for reflection. And the time it takes to come back gives you an idea of how deep it is, the reflection. And radio and radar penetrates ice very well. As soon as it hits water, it bounces off because the water is an electrical conductor and it will dissipate the wave. But because ice is not as good a conductor as liquid water, it acts as a good transmitter of radio signals. So we've flown radar, say, over Antarctica, and we now know that there are mountains underneath Antarctica, right? We know we can see through the ice. Same with Greenland. That's another way that global warming is proven, is by actually measuring the depth of the ice on the Greenland ice cap or the Antarctic ice cap. And we can tell if that cap is getting thinner over time because we can quite accurately measure it. So we've done the same for Mars. I can't remember which spacecraft has the radar on it, but it might be Mars Express. But it's been able to send radar down onto the planet and detect these subterranean lakes both measure the profile of the ice cap and also see if there are lakes, because if there are lakes, then they soak up the radar.
Hmm.
They kind of mess up with that.
It's amazing what we can do just from looking and stuff. That's just
oh yeah. The other thing is we do is that just to sort of diverge in a little bit of remote sensing here, is by analyzing the detailed way that the spacecraft orbit the planet, we can measure the planet's interior structure, because we can build a model that explains why the spacecraft got tugged on a little extra or a little less by its gravity based on the shape. That's one of the cool parts of Jupiter, is that the Juno mission is dive bombing Jupiter continuously. And they've discovered that Jupiter's core isn't spherical. It's sort of a funny, odd shape. It's not that distinct. And it's all based on the way the Jupiter is tugging on the spacecraft every time it flies by.
That's wild. And I remember reading something about how, I think it was Curiosity, they reprogrammed, or they found a new way to interpret the accelerometer data based on what the rover was driving over. And so that if it bounced in a certain way, they could figure out what rock was underneath it, essentially, which I just find it so cool that you can take stuff that was meant to do one thing and just go, oh, I'll just pick up new data and do something else completely different now.
And that's the beauty of NASA's approach, is that they release the data, they release the information to the scientists on the project team first. But once they've had a bit of a head start, then they release it to everyone. And so researchers from another institution or from even citizen scientists can then access that information and analyze it in perhaps ways that weren't thought of before, and do new things. And we are constantly, you'll learn something new about Saturn that nobody knew about because somebody went back and analyzed the data from Cassini or another spacecraft from years ago in a new light. It's great.
Super cool. Kate has another question, and it's on lakes, and then I'll let you go back to talking about Mars. Are there any planets that could not possibly have water or underground lakes due to geophysical properties, proximity to the sun, or something like that? So like, I'm thinking Venus could not have water lakes because it's like 400 degrees or something.
It depends. So the way that heat works on a global body like Venus, or even on Earth or Mars, for example. So the interior of Earth is still hot because it's still collapsing and it's still cooling off from formation. It takes a while for the heat to leave, but also because the Earth has a lot of radioactive elements. So uranium, thorium, potassium, all these elements that are radioactive, they generate heat in the interior of the planet. And in fact, one of the early, I forget which explorer it was or which scientist it was, calculated that based on the rate that Earth would have cooled down after formation, that supported the idea of the Earth being only a few thousand years old, because he didn't know that the radioactivity was also there to maintain the heat. So you have heat from the core generated by radioactive elements and by its collapse, but then you have heat coming in from the sunlight on the outside. And so in the case of Venus, there's probably both happening, but there might be a layer, a subterranean zone, well under the surface of Venus where it's more temperate and the water hasn't been kind of boiled away. I'm sure everything near the surface is boiled away, but we don't know. And that's why with phosphine discovery and all of these cool things, planetary scientists have been saying, enough about Mars, for goodness sakes, let's go to Venus. But Venus is really difficult. It's really hard because it's so hot and hostile. But I think it's worth looking at.
You have to get you have to get aircraft essentially to the right level on Venus so as not to melt upon arrival.
So yeah, we have frozen water on Mercury in the deep craters near the poles that never see sunlight. And then we don't know about Venus. I'm sure there's water somewhere, even in the temperate heights above Venus's atmosphere. There could be there could be water. I haven't read up on Venus as much. And of course we have Earth, we have Mars, we're discovering water on Mars. And then Jupiter and Saturn themselves, not so much, maybe not so much water, but their moons for sure are loaded with water and subsurface oceans. And we're finding water all the way out to Pluto and beyond, hopefully beyond. But even Pluto, we think, might have a subsurface ocean now. It's really exciting.
Yeah, it is exciting. So I guess the ultimate answer to the question is it's hard to rule stuff out. As far as I know, there's no, I mean, I guess you could talk about the gas giants don't have lakes on them because they're all mostly gas. The other cool thing too is that when we're researching exoplanets, we're finding stuff that is nothing like what we have in our solar system too, right? So we're finding Earth-like planets that are huge, or Jupiter-like planets that are like right next to the sun and stuff like that. So there's a lot of planets that aren't represented in our solar system out there that we.
Yeah, I'll show you a neat book I read this year. Let me see if I can find it here.
Imagine life.
Imagine life. So the authors go through each scenario. So ice planet, planet that's tidally locked to the sun. So one side is always day, one side is always night. Giant planets, tiny planets, TRAPPIST. It's a great book. It's neat. It explores all those scenarios for life around exoplanets. All right. Okay, let's talk about Mars 2020 for a minute. So Mars 2020 has been renamed Perseverance, and it shares the same chassis as the Curiosity rover, so it's also nuclear powered, and it launched a month or so ago. It's on its way. There are 3 missions on their way to Mars right now. One from the United Arab Emirates called HOPE. Let's see. Perseverance, and is it India or China? China, I think, has sent a lander to Mars. They're all on their way. And again, because there's a big flurry to go to Mars because it's 2020 and the planets are close to one another. So let's see here, Perseverance. So this is sort of the more natural view of Mars. So here's that Syrtis Major dark patch that we were talking about through your telescope that you might see. And just alongside it, there's this sort of big plain called the Isidis Planitia, or plain. And down here, there are a couple of big craters. And there's a small crater called Jezero. And Jezero is the target for the Mars 2020 or Perseverance rover. And I'm just going to show you. Let's see if I can show you a picture of Jezero. Here we go. So this rover is going to be a robot biologist. So let me just bring this on here. I'll bring this down.
Perseverance, you mean?
Perseverance.
Oh.
So rather than a robot geologist that Curiosity was, Perseverance is a robot biology. And this Jezero crater is actually, it's an ancient river delta. So you can see this sort of a spillway, and all this material sort of spilled into this ancient plain. And this is the ellipse that they're targeting to land within, this little ellipse here. And so they're going to actually drive the rover kind of up the delta. And as they go, they're going to be looking for mineralogy and geochemistry that might have supported life in the past, or that might even now support life. We don't know. I don't think anybody expects them to necessarily, pick up a fossil at this point, but they're open for anything like that. And the other unique thing about the Perseverance rover is it's going to actually collect samples, put them in little canisters, and deposit them for a future mission to come and retrieve.
Oh, that's cool.
And that's not all. Let me just see if I can. Perseverance.
Oh, I've heard about this.
It's also going to have a helicopter on it. So under the belly of the rover, tucked away, there's going to be a drone, basically looks something like this, two rotors, counter spinning rotors. So once it's landed safely and everything's ready, the rover will detach from the belly of Perseverance. Perseverance will drive off, and once they're ready, then they'll lift off, and it'll be the first, first flight of any object not on Earth. So
That's
it'll be
cool.
first time humans have actually flown anything on another world.
Flown instead of just like violently thrown at something.
Yeah. Powered flight. So they're actually going to be able to hop from place to place and maybe scout ahead a little bit. And so it's amazing, really cool. In my notes, I think I've got it here. The landing is due on February 18th, 2021.
I'm going to mention this now. We don't have any plans for that day yet. I'm sure by the time that it rolls around, we'll host like a watch party or something like that online. But I know that we can't get together and hang out right now, but being online at the same time as this stuff is happening is so much fun. If you haven't done it yet for like launches or landings, it's worth it. So keep your eyes out. What was that, February
18th. It's here on
February 18th. Okay. Keep an eye on our social media, at least. I'm sure we'll post something.
Yeah. So that's kind of what I had prepared. I'm happy to answer questions. We can stick with Mars. We can look at other things. I do have a neat trick I could show you in Stellarium if somebody's interested. But before I jump out of Starry Night, maybe I could open.
Let's answer questions for now, and then we can show the neat trick. There's a question that I was actually going to bring up as well from John saying, is there enough atmosphere to support the drone in flight? Because that's one of the biggest challenges with Mars, is that it's got some atmosphere, but not much. And so if you're trying to land stuff on Mars, you have to use both rockets and a parachute, because the parachute's not enough.
That's right. Yeah, the air doesn't get thick enough for a parachute to work until it's dangerously close to the Earth. So the parachute's only part of the landing process for Mars. But yeah, the rover is going to be designed with oversized blades, oversized rotors, to account for the thin atmosphere. And it's also going to be very light. It's limited instrumentation to keep the infrastructure light and the helicopter able to fly.
Mm-hmm. You just have to make the modifications. The problem is when you try to do that while also flying it there. So you have to, that's why they have the little quadcopter helicopter deal inside the rover, because if they tried to just get the helicopter there in the first place, it wouldn't be able to make it through the atmosphere terribly well.
Yeah, and the other is that the Mars gravity is about 1/3 of Earth's gravity. So you also have that advantage helping you. So it takes less effort to lift off the planet.
Mm-hmm. There's a question from Al saying, why is Mars so hard to land on? And I think generally speaking, it's that combination of needing to, like on Earth, you can just use parachutes, easy peasy. But on Mars and on the Moon, you can just use rockets. You don't need a parachute as well, because the gravity is so little and there is no atmosphere that you can just go like fire the rockets just before you land. But Mars has a little bit of atmosphere and more gravity than the Moon. So it's just that like tricky zone.
Yeah. A little aside here, if anybody's interested, is Europa. Everybody is very keen to go to Europa because there could be a subsurface ocean, and a warm, salty subsurface ocean that might be hospitable to Earth type of life. And so, but Europa has no atmosphere. So, and it's ice on its surface. So you can't use a parachute. If you use a retro rocket, you're just going to melt the ice underneath you. So that's tricky. And also you don't want to, blast the surface and sterilize it where you land, because then you're going to kill everything that you came there to find. So that's been a real challenge to figure out how to manage to land something on Europa. It'll probably end up being similar to the thing they do on Mars, where they use retro rockets to get it close, and then they lower it, or they'll drop it with airbags and let it tumble, something like that. But yeah, it's tricky.
And I attended a conference a while ago where some NASA folks were talking about parachutes, and the fact that we really like don't know what makes them work that well. It's a bit of an art form more than a science, in terms of like they take the stuff that's already worked and they just kind of modify it, which absolutely blew my mind, that this is not like well documented. It's well documented. It's just not really a science. It's more like, oh yeah, what worked? Oh, we'll go with that.
This is a neat little aspect of Starry Night. So I landed us at Gale Crater, and I'm looking at the sky from Gale Crater on Mars on October 4th and 5th. So now, and of course, for us, Mars is opposite the sun in the sky, but for Mars, Earth is in conjunction with the sun, right?
Right. So
And
it would be at this time of the year that if there were going to be a transit of the Earth.
You can get a transit of Earth from Mars. Yes, you can.
That's cool.
In theory, yeah. I may have written about that a long time ago. I don't remember at the moment. Somebody could Google it if they want to, but if they can find the date, I can show it in Starry Night. But what that means is that Earth's being illuminated from beyond by the sun. So if I magnify the Earth as viewed from Mars, then Earth will show as backlit. Let's see if we can get this to work. Here we go. I don't know, can you see the little ring? There's a little bright ring of the sunlight diffracting around the Earth's atmosphere, right? And if I center, I think I can center that and change the date. If I advance, whoops, let me just get that. I'll center the Earth. If I go back in time, then I can get the Earth to be a crescent. And then as it gets near the sun, it's backlit. And that's unique to Earth because we have a thick atmosphere. Yeah, we get that ring. You may have seen the pictures that New Horizons took after it left Pluto. It looked over its shoulder back at Pluto and got the blue ring of atmosphere around Pluto because it has a thin ring. But Earth, of course, would make a much more dramatic ring, backlit ring.
We're going to be romantic about it because we do that around lunar eclipses. We're looking at the sunsets, all the sunsets on Earth, when you see that backlit and sunrises.
So I thought that was a cool little thing that we can do here. Any more questions?
There are, but I'm looking up the dates of transits of the Earth from Mars on Wikipedia. I'll get there. Apparently there was one on May 11th, 1984, and the next one will be November 10th, 2084.
2084, November?
November 10th. It doesn't give you the exact times. Come on, Wikipedia.
Oh, that's okay. I'll figure that out. So if I go Earth, and let's see if I can center the Earth in this view, best time. Okay, so Earth is right beside the sun. Okay, I'm just going to center on the sun, and I'm going to advance.
It's November 10th, FYI, November 10th.
Oops, let me hide the hide horizon here. There we go.
Oh, there it is.
Okay.
Wow, that's actually surprisingly big. Okay, it was big for our benefit.
And you know what? The cool thing is that you'd get the moon as a bonus.
That's pretty cool.
Yeah.
Okay, so if any of you all are still around in 2084 and we've made it to Mars, November 10th is the day to keep an eye out for that transit.
Well done, Jenna. Thank you.
No worries. Okay, back to the questions that people actually wanted to know the answers to instead of the ones that I want to know the answers to. Janine asked, since you are a planetary geologist, if you have any updates on the geological drilling on Mars. I know you mentioned that the surface is red and the underside is gray, but do you have any updates on any of the research that's going on that front?
I haven't looked recently, but I recommend that folks watch the Planetary Society. planetary.org. They're a great source. I can bring up the web page here. And let's see.
I'll grab it too.
They've got some.
They're the Bill Nye, not the Bill Nye Society, but Bill Nye is the
Bill Nye is their CEO. Yeah.
CEO. Yeah.
Let's see if we can find space missions. Here's some upcoming things. Oh, you know, later on this month, OSIRIS-REx is going to take its sample off Bennu. The asteroid. Bennu. Yeah.
That's exciting.
On October 20th. Yeah. February 18th, Perseverance landing. Anyway, I won't go into it now, but this is a good site to watch for that kind of thing.
It is in the description, so you can check that out. There's a question that I'm not sure, I certainly don't know the answer to, about where the oxidation on the surface of Mars comes from, whether it's from the UV radiation from the sun or Mars's atmosphere. I have no idea.
Well, the sun can contribute for sure. I don't know the relative importance of each factor. It's also possible that some of the weathering occurred in the past when Mars was wetter and there was more atmosphere, there was more water around. Yeah, it's something we're looking into. I don't have the latest on that.
Mm-hmm.
But I can find you I can find you a photo. I think I have a GIF. Let's see if I can find this GIF of it.
You're a GIF. You say GIF. You don't say GIF.
GIF. I say. Let's see if I have this one here. So here's guy.
While you're looking it up, there have been a couple people saying they're not going to Mars because it's a one-way ticket and all that sort of stuff. And there's a David Levy, he's a Canadian comet hunter, and he gave a talk for us, and it's up on YouTube if you want to watch it. And he played a song called "On This Side of the Moon" by, I'll look it up. And it's just super cute. It's essentially like, I'm happy where I am. I'm good here. I don't need to go off the earth.
Okay.
By Alabama.
So this GIF is before and after drilling.
Oh, cool. You can see that gray.
I think this is the very first drill hole ever made on Mars.
Yeah, because that was that little, like the one that can drill 16 inches down, right?
You can see it's the same place because you've got this little vein of
oh, cool.
Almost looks like quartz or something in there. So yeah, and you can find other pictures of other holes that they've drilled, and that's consistent every time. They get a light gray sort of powder.
And I guess it's red. It would be, since they're unlike on the moon, where if you step on it and leave a footprint behind, there's no weather, and so it's going to be there for a long time. On Mars, there is wind and clouds and that sort of stuff, and so to get that gray color, you'd have to actually drill into the rock itself and not just like dig a small hole, I guess, huh? Or like shift the dust.
No,
around.
that's not necessarily the case. So one of the rovers, its wheel jammed up, and so it had to drive backwards because it had to drag its wheel. It's one of its front wheel became its rear wheel driving backwards, and as it went, it would excavate a trench behind it. And once you scrape off the reddish soil, it exposed in some cases some bright white soil, other types of soil undisturbed.
Oh, cool.
Yeah, it's all to do with weathering. What else?
And that's all we have for questions so far. Let me check YouTube just to make sure I'm not missing anything. If anybody has any extra questions, let me know. There is one that I'm not sure if like, I'm not super well versed on the details of each of the rovers that are going up there, but one person asking, they're into stereo photography, and are there stereo cameras on the rover? I have no idea. I'm not well versed on the mission.
Guess what? I happen to know this one.
Oh, yay!
So on Curiosity, they sent up, you know how it has a mast with a camera head that swivels. And the camera, as far as, if I may have the details, some of these details wrong, but basically they have a wide, low magnification camera, and then they have a macro camera, sort of two. So you'd think they were stereoscopic, but they have completely different focuses. So they haven't been able to work them as stereoscopic. But I believe that the Perseverance rover, they were able to make an arrangement where they now can get stereographic imagery. So they're going to have stereo view on Perseverance, and I think a microphone. So they'll be able to listen to the wind, the air.
Oh, that's going to be really cool. We're starting to get Mars in many senses here.
Yeah, yeah.
That's very neat.
What I wanted to show here, so we got a few minutes to kill, so that's fine.
We do.
So this is the famous Valles Marineris. So this is the big canyon that runs across Mars. And a little bit to the west here, these are the Tharsis region where the big volcanoes, the big dormant volcanoes are, including Olympus Mons, which is the biggest volcano in the solar system. And this canyon would stretch from coast to coast in Canada, just to give you an idea of scale. So Vancouver to Halifax, sort of across the length of that canyon. So it's also about the biggest canyon in the solar system as well. Now, remembering that the color codes indicate that red and white is highland and blue is lowland. If I swing this around to the opposite side of the planet, then we find this. This is a really deep valley, deep basin in the backside of Mars, hidden on the backside of Mars. You don't see it visually, so I'll just change the picture so you can see it Viking shaded. So that's this Hellas. Oh. That's that bright Hellas region that I was showing you to look for in your telescope. It represents a basin, a low-lying area on the planet. And what's cool to wonder about, let me just get back the laser altimeter, is maybe something slammed into Mars, excavated that basin, you know, that early billiard gallery of this early solar system, slammed into that side of Mars, created such stress that it produced the volcanoes and the fracturing on the opposite side of the planet, just like the eyes bugging out of your head when you get hit in the back of your head. So that's the sort of cool things that we can do with planetary geology when we start looking at the planet from that aspect.
That's so cool. What a neat theory. Huh.
Now the moon's a different situation because the moon is tidally locked with one face kept towards the Earth. Almost all the dark maria on the moon are on the side we see. Only a few % of them are on the far side. And that's because the gravitational tug between the Earth and the moon have preferentially caused that upwelling of the magma on the side facing Earth. So yeah.
That's cool. All the stuff that you don't think of when it's not on Earth. I mean, I say you generally, you certainly think about it. I don't. Well,
that's what folks like our friend Sarah Mazrui and people like that, you know, that's their training, that they think about these things. And I think it's cool.
It's pretty neat. It's neat to, and it's also just neat to speculate what goes on out in space.
I could show you Mars's gravity field. So you can see that where the rock is deeper, the gravity is stronger. So the red and white gravity is heavier. So you'd actually weigh a little bit more if you were here, and you'd weigh a little bit less if you were where it was purple. And so where the mountains are, there's thicker crust, more rock to pull on you, so you weigh a little more. So you can get that effect. And you can do the same thing with the moon. It's really cool. Or if I show you Mars's magnetic field, it's very chaotic.
Oh, wow.
Right? It's small, it's weak compared to the Earth's, and it's quite sort of random, the way, unlike the Earth's, which is much more structured.
Okay, so we have a bunch of questions now because
we waited
long enough. There's a question from Douglas, and I promise that I will get to the ones in the Q&A, don't worry. Is it possible that it was Mars that made the glancing blow that produced the moon? I would say no, because it's too far away, huh?
No, but we think it was the size of Mars.
Wow.
Yeah. So to calculate what happened and work backwards, I think they called this, I think it was called Thea. It might have been the object, the name they gave the object. I forget right now, but they think it was Mars-sized, the glancing blow of the Earth. Yeah.
Wow. That's insane. Yeah, Phil confirms Thea.
Thanks, Phil.
Do you have any interesting details about Mars's moons? Is there any, because Jupiter and Saturn's moons are interesting and varied. Is there anything specific, like particularly interesting about Mars's moons?
So I happen to think that the best way for humans to explore Mars would be to create moon bases and then send robots down to the surface. So our challenge with the rovers that we're sending to Mars now is that we have to issue them commands with a time delay, right? Right now, the delay is 3.5 minutes, but a year from now, it's going to be 20, whatever we said it was, 28 minutes.
21, yeah.
So if you want it to drive and do something, you got to be careful, plan what you're going to do. Whereas if you had an astronaut sitting on Phobos or Deimos, she could teleoperate a robotic explorer almost in real time, right? Pick up a rock, turn it over. Now that one's no good, throw it away and move on. So people often say that a trained geologist could do as much in 20 minutes as the rovers have done their whole time on Mars practically, because, they just know what to look for and they're so quick at it.
Yeah, I guess
maybe that's exaggerating. But so what I think is we'll do is we'll end up maybe excavating a base, digging a cavern, and setting up shop on one of the moons. And then, because it's much easier to get back and forth to Earth from the low gravity of the moon than it would be to try to lift a rocket off of Mars again. The gravity well is intense. But, all the options are on the table, right?
They are. I'm further into, I know you've all heard me talk about how much I like The Expanse, the book series. I'm further into the second book now than I was before, and I'm very excited about the whole. I love the talking about gravity wells and how the physics of getting around the solar system if we were to expand where humans are within it.
This little animation is showing you how the moons move if you view them from Mars, and you can see that Phobos moves a lot faster than Deimos.
They're moving. Why are they moving in opposite directions?
I don't think they are necessarily.
Oh, you're right. Deimos is just
moving platform thing.
Right.
I haven't looked at that aspect of it, but
cool.
Yeah.
Okay.
Yeah, they're both also tidally locked, so they keep one face towards the planet, just like our moon does. What else have you got?
We've got some stuff back on the surface of Mars where we are right now, but if we can look at it again, some ones that I missed when we were looking at it that I should have asked. Stuff like would plate tectonics have created the rift that Mariner Valley?
Well, Mars is not dynamic now because it's cooled off and solidified, but it's possible that it had some kind of internal dynamics in its in its early history. I'm not sure, but that's the kind of thing that we do want to find out more about.
It's hard to know. I mean, again, we're looking at this right now. We don't have that much of a time scale on any of this stuff. So, and on Earth, you can look at a bunch of different evidence in different areas about what has happened in the past, but we are not on Mars, not personally. So it's a lot harder to figure that stuff out. And of course, we've been looking at it on Earth for years.
And, I should have mentioned, people ask, well, why haven't we gone yet? Well, you want to launch to Mars when the two planets are relatively close, but it takes 6 months to get there. By the time you've gotten there and gotten settled, you're now on the opposite side of the solar system from the Earth. So you kind of have to wait a year before your geometry is optimal again. So it's really a 2 or 3 year commitment to send humans to Mars. So we have to make sure that we know how to feed them, keep them safe from radiation, keep them mentally healthy, not to drive each other nuts, crazy, you know, that kind of thing. Get on each other's nerves. So,
and so yeah, there's a ton that goes into it. And there was just some research published that the surface of the moon may be more radioactive than we initially thought. So we don't even know some of the details of what's going on the moon, much less what's going on Mars. And also, I mean, if you think about, we went to the moon a bunch of times in the 60s and 70s and then never again. And that was because there was this big political race where all the money was going into that project. And we don't have that kind of competition right now. So it costs a lot of money to send people to space. And it's not where everyone's priorities are right now.
Well, of course, President Trump has kind of declared that Americans would be back on the moon in 2024. So NASA's actually actively trying to achieve that goal. That's the Artemis program. And Apollo and Artemis were the siblings in Greek mythology. Artemis was the woman, Apollo was the man. So the thinking is that the next person to set foot on the moon will be a woman.
Yes.
Which I think is fantastic.
Yeah, that'd be awesome. Further questions, not so much about space exploration, which I could talk about for hours, but we only have 5 minutes left. Can Chris comment on Mars meteorites and the mechanism for how they get here?
Good question.
The poor person's space program doesn't cost anything as a sample comes to us.
So objects that are orbiting the sun stay in orbit because they have an orbital velocity, right? And you could emulate this at home. If you put a tennis ball on an elastic cord and swung it around, you could get the cord to be straight and the ball to go in a circle. And then if you swing the ball harder, the cord will stretch and the orbit of the ball will be greater. So that means that Mars has more orbital energy, so to speak, than Earth does. So in order for us to get from Earth to Mars, we have to send something faster than Earth, something orbiting faster than Earth, which is what that Hohmann transfer orbit that I showed was. And so we give it a strong enough boost from the Earth so that it ends up traveling at the same speed as Mars does when Mars is there at the right time. So what that means is that an Earth rock, if an Earth rock got blasted into space, it would have to get energy from somewhere. The blast would have to be vigorous enough to get it out to Mars's orbit. But conversely, to get from Mars to Earth, you need to lose speed and slow down. So that's what you do when you do orbital mechanics, is you fire your retro rockets and the spacecraft then starts falling to the Earth when we want to land. We just slow it down and it starts to fall to the Earth. So it's actually easier to get from Mars to Earth. And so the Mars meteorites that some of our friends have bits of and you may have heard of, they're basically an ancient impact, knocked some material into space. That material could drift in space for many, many years, and then ultimately, gravity doing what it does, get caught in Earth's gravity and fall to the Earth. So that's where we find bits of the moon on the Earth, we find bits of Mars on the Earth, we find bits of the asteroid belt, if you like, on the Earth as well.
There was a request to talk about asteroids and samples of moon rock and stuff like that. So maybe at some point we can talk about that. If I'm allowed to go back to the office and pick up our samples, because we could do some actual.
Yeah, I have. I know a rascal who's something of an expert, amateur expert on meteorites and collecting meteorites. I'd love to do a session and have him as a guest. And
cool. Okay, we'll figure it out.
Yep.
The last question that we have. Oh, one real quick one. What was your book that you were showing us again?
Imagined Life.
Perfect. Okay. I have commented on that question so that you guys have it written down, but the video's up on YouTube, so you can always go back and look it up. And lastly, do you have any cool facts about Olympus Mons?
Olympus Mons.
It's tall, big old mountain.
They have detected from time to time clouds around it. And I'm not sure whether the clouds are created by the sort of dynamics that we get clouds over mountaintops on Earth, or whether it's evidence that the volcano is emitting anything. It's more likely the former than the latter. If you're into sci-fi and you read Kim Stanley Robinson's Mars books, one of the cool plot points is that they built a space elevator off the top of Olympus Mons. And because it's already so high, it's less to add to the height to get to the space elevator's orbit. So I thought that was cool. And
That's
something amazing happens that I won't spoil.
Got to save those spoilers. No spoilies in here.
Yeah.
Okay, I think that's
Yeah, we
it.
find volcanoes everywhere. I mean, we have, so Mars, it would be a, a mineral type volcano, but we have cryovolcanoes, which are ice volcanoes on Ceres, on the moons of the Jovian planets.
Enceladus.
Yeah. And then we also have, mineral type volcanoes on Io as well. Io, I think, is the most geologically active body in the solar system.
Mm-hmm.
And Io is so active because it's being constantly massaged by the gravitational tugs of Jupiter and the other Galilean moons. And it just keeps massaging it like working Play-Doh and keeping it warm. And that has to release that energy in volcanoes.
Cool. Okay, we're almost done all the questions. I would say we are done all the questions, but Eric Briggs threw out a really cool fact in the YouTube chat, which is that Phobos takes less than one Martian day, to go around the planet. And so to an observer on this Martian surface, Mars actually overtakes the sun, which is so cool. And I think that's, that one last question has appeared. Oh, it's okay. Live long and prosper. Thank you, Joe. Thank you so much, everyone, for joining us. It's been a blast. Get out observing this week, because this is the week to do it. And join us for our live stream on Tuesday next week, where we will all be sharing views of the sky, and we will have our guest speaker talking about microbial life. So or the possibility of microbial life on Mars. So bring your questions about that, and have yourselves a wonderful week. I think that's all I have. I'll
leave you with the one little Stellarium pro tip that you can try. So what you can do is you can go into F4, viewing options. You can go into markings. You can ask for the anti-solar point, and that's the point in the sky exactly opposite the sun. When you do that, you can see the anti-solar point is labeled here. And so at opposition, Mars is opposite the sun. So if I change my date to, I'm off a little bit, somewhere in the vicinity of October 13th, the Mars is closest to the anti-solar point. So that's cool. That's what opposition really means. Mars is opposite the sun in the sky.
Cool.
You can play with that little thing. You can do that for any of the planets. They'll all the planets farther from the sun than Earth is will have their rendezvous and opposition near the anti-solar point.
Right. Venus and Mercury don't count. They're too close. All righty. Thank you so much, Chris. That was a blast. I learned a ton. I hope you all learned a ton as well. And we will see you in 2 weeks when we have our next session. I don't remember what it's about. But until then, right now, we're just distracted with how much Mars stuff we want to see. So head out there, check out Mars, tag us in your post if you want. Chris, you're Astro Geo guy. We're RASC, or Royal Astronomical Society of Canada, based on the platform. And we'll look forward to seeing your pictures. Are you Astro Geo guy, Chris?
I'm Astro Geo guy. I was going to show you. Where's my?
Oh.
Here it is.
I promise we are going to wrap up. We will.
We are going to wrap up, but I just wanted to show you this. Whoops, that's the wrong one. Where's the one?
I'll quickly say that our next episode is on Guinness Out of This World Records. We're going to talk about the Guinness records of the space things. So it should be a good one.
So let me share. Let me share. Zoom. Share. Screen one. Sure. I just want to show you this picture, this little teaser for next week. This is a picture of Mars taken through the David Dunlap Observatory's 74-inch telescope.
74 inches.
On a not very good night. 74-inch diameter telescope.
bigger than me.
Yeah.
So
All
we're
right.
gonna take a look at it. We'll look at Mars. We'll check out Mars maybe through that telescope, and we've got a couple other telescopes lined up as well.
All right.
Okay.
And we're done.
Thank you for that. All right, we'll see you all next week at that event on
Looking up at
13th.
Mars.
Clear skies.